Simplify the radical. This time it is a fifth root, so if something is going to come out of our root, we need to have sets of 5 of something. I'm going to make an empty fifth root for my answer, so it is ready. We need to split apart our 128 into the smallest factors we can. We should always try to divide by 2 because it's the smallest factor that we have. We can divide by 2, that would be 64. We're going to get a bunch of 2's to come out of this. 2 and 32. 2 and 16, 2 and 8, it just keeps going. 2, 4, 2, 2. Don't stop until we get a 1 on the bottom. My goodness, that's a lot of 2's. All right, I need to find them in sets of 5. So if I'm circling up 5 of them at a time, 1, 2, 3, 4, 5, I have to use all 5 of those 2's to cash out a regular 2 on the outside. How many 2's do I have left over? Well, I have 2 2's left over, so I'm going to multiply those back together and call it a 4. Put that on the inside. For the letters, if I look, a to the 4th, I already know that that's not going to be enough to come out of my fifth root, so I'm going to leave it alone. A to the 4th. B to the 5th. Well, that's exactly a set of 5, which means I would have no leftovers. If I write this one out, B, 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 5 B's, B to the 5th power. I'm talking about sets of things. I have a complete set of B's, and I have none left over. So I have to use all 5 of those B's just to make a single B on the outside, nothing left over to put on the inside of the radical. C to the 6th. Okay, if I think about it, C to the 6th, that means I can get 1 set of 5 and 1 left over. So you could just say C to the 1 on the outside, C to the 1 on the inside. First power, C to the 1. If you want to check that, you could always write out 6 C's, circle up 5 of them, and say, oh, I got 1 set and 1 left over. So I'm going to write my answer with 1 C on the outside and 1 power of C on the inside. This question is done.